Hello, this is Mr. McLeod, and in this video, we will be looking at string literals and strings and how they're treated specially when creating objects. So the first thing we're going to take a look here at is how string literals are handled. So in Java, string literals are kept track of in a pool of strings in memory that Java will use to access any string literal throughout your program. So if you have multiple string literals that say the same thing, they will all point to the same object. So if we make our pool here, the first thing that gets added is mat. So see this string mat, since it's in quotes, it's a string literal, and therefore it is added to the object pool of strings. We say mat right here, and that means the next time we encounter the literal mat, it will just point to this same object. Okay, and this is saying A is going to point to mat, so we're going to say this variable A is pointing to mat in the pool. Okay, so then if you look at the next line, string B is a new string. So the keyword new means this is going to be a new object created over here outside of the pool. And it says it's going to be a string created using this string literal at. So as soon as we encounter this string literal at, that means at is also added to the string pool. But in this case, B is not going to point to the pool because B is being set equal to this new string. So the new string is going to say the same thing as the literal at, but it will be a different object. And so B is going to be pointing to that object. Okay. Then char M, since this is a char, this is not even an object, right? Remember that primitives are not objects. So this is just a primitive value that stores the number that represents M in the ASCII chart, right? So there is no object being created there. However, in the next line, there's a lot going on here. So when we say M plus B, since B is a string, that means it's going to concatenate B with M. In fact, we could rewrite this line. This line is equivalent to basically a string added to B. So we could deal with the M plus B first. Okay. And then that's going to create an object. And then let's put parentheses to indicate that after it creates this object, then it's going to add TER to that. So I think the parentheses is going to help you see that first it's going to do one thing at a time, right? So any string plus something is just going to tack the string representation of the other thing, so the M, to the, in this case, beginning of B, right? So it's going to create a new object that is going to say MAT, because there's an M and then B currently says AT. All right, now notice there's no arrow pointing to this because this is never assigned to a variable. You could actually say this is like an anonymous object because there's no variable that ever points to the string M plus B. But it is used immediately because then it is combined with the TER. So then another object is created. And this one says a combination of MAT plus TER. And in addition to that, you'll notice that the TER is not in the string pool yet. So that gets added to the string pool because TER is in quotes. So that's a literal. So we're going to add that over here. And then the combined string MAT plus TER says matter. Okay, so notice this is and then we're adding that plus TER. And notice there were these two objects created, MAT and then MATER. And then the one that B is going to point to is the MATTER, right? The final result. Oh, and then TER was also created, right? So actually that one line created three objects, right? So we created the literal TER, and then the first two, the first string combined with the character M, MAT, and then that string combined with TER to make matter. So there's three objects created. Okay, and then B is now going to point to this. B gets set to the final result. Okay, which means we now have a couple of things that are garbage. I should point out. B is now pointing to MATER instead of AT, so this is garbage. And then MAT was actually garbage pretty much immediately after it was used because it never got assigned to a variable. It was just used in the middle here in the concatenation. Okay, and all right, so we're gonna leave it at that for now as far as the garbage goes. Okay, so then string C in the next line, we're gonna have a new variable. String C is a new string MAT. This time the MAT has already been added to the string pool, so this does not create a new object. However, the new string does. So we're going to make a new object that is going to say mat. And that's the one that C is going to point to. All right, and then in the next line, we got a whole bunch of objects created here. So we've got, well, we got new here, and new here, right? That's three objects. And then the TER is already in our pool. So that means that is not going to get created again. It's going to just use the existing TER. However, let's go ahead and make our other objects. So we said a new string which is going to say it's the same thing as this new string, which is going to say the same thing as this new string. Okay. So new, new, new. So they all say TER. But only one of them is pointed to, right? So D points to the new string, which says the new string says the new string. So both of these other two new strings are also anonymous objects because they're created but never assigned to a variable. So there's no reference variable to access them. So they immediately become garbage after they're used. So these are now garbage. Okay, and then in the next line, we have C.substring. So since C.substring returns a string, that means that's going to create a new string. So we have a new string that says from 0 up to but not including the second character, right? So basically just the first character of C. So if we look at C right now, it's this. So the first character is M. So that means this is going to be a substring that just says M. And then it's going to combine, concatenate that with a string that says AT, this literal. Since we've already got a literal that says AT right over here in the pool, that means there is no new string created there. So we can just concatenate them, and the new string that is created is the final result of adding M to the AT, and that is going to say max. Okay, and then that is the one that C is now going to point to. So C is no longer going to point to this mat. Now it's going to point to other mat. And that also means that we've got some more garbage here. So since this mat no longer has anything pointing to it, it is garbage. And this M this M is immediately garbage after it was used because that was the substring that was an anonymous object essentially, since we never assigned it to any variable. It just was used quickly and thrown away. Okay, and then right here, we say C dot to uppercase. Now, notice the interesting thing here is that we call to uppercase, but if we look in the API, you'll see that to uppercase returns a string. And if you also think about what you know about strings, strings are immutable, which means there is no method that actually changes what an existing string says, right? So since this object here says mat, it's always going to say mat. We could assign C to a different string object that says something different, but we can't change what this string object says. So knowing all that, we know that this is not going to change this mat to uppercase. Instead, it's going to just create a new mat that is all caps, except that we never said any variable equals this, so nothing's pointing to it. So immediately it's garbage because we didn't actually use it. Then we say D equals C. So that means D is going to point to the same thing that C is currently pointing to, which is this mat. And that means what D used to be pointing to, since nothing else is pointing to this tur, that tur is now garbage. Okay, and then at the end here, where we're printing C, this was just to call attention to the fact that since this C dot to uppercase can't actually change what C says, C is still going to say MAT lowercase, right? So that's what C is pointing to, this object that says, okay, so that's what that's going to print. And so then if we wanted to count how many objects were created and how many objects are accessible, we can just go through and look at our diagram. The one thing I'm going to add at to the diagram at the very end is I'm going to make a note of any strings that are in the pool that are not being pointed to by any objects, right? So these two, the AT and the TER, we're not going to count those as accessible because we're going to strictly say objects are accessible if a reference variable that's in scope is actually referencing them. Okay, so anything that doesn't have a variable pointing at it is not accessible. Even though technically the AT and the TER are not going to actually be collected by the garbage collector because the pool is going to be maintained, right? You could say that the pool itself references it, but we don't really have a variable that's pointing to these. Okay, so doing that, we can count how many objects were created by simply first looking at how many objects did we draw on our diagram. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 objects created. And then the objects accessible are just the ones that have variables pointing to them. So we've got this one here, this mat is pointed to by C and D. By the way, if it's pointed to by 2 variables, you could say each of those variables is an alias of this object, right? So an alias is just like another name for the object. You know, like if I named Ted and some people call me Theodore, then that could be another alias, right? Okay, so there's 1 there, and then this B is pointing to matter, right? And then the A is pointing to this mat in the pool. So there are 3, 1, 2, 3 objects that have variables pointing to them. That's how many are accessible. All right. I hope this video was helpful in helping you understand how string literals and strings are handled for the purpose of counting how many objects are created and accessible, and helping you understand how the pool works. And I will see you in future videos. Goodbye.